Okay, guys, we are in Advanced Math Trig. If you are in honors and you have class mods 2, 3, and 4, you are putting 42720 in the top left corner of your paper. So, hope you had a great weekend. It is Monday, April 27th, 2020. The title is Geometric Sequences. If you are in Advanced Math Trig and you're in Mod 7, you guys are taking these notes and learning this material a little bit later in the week. For you, you're putting 5-1-20. So 5-1-20, Friday, May 1st, in the top left corner of your paper. Again, if you're in Advanced Math Mod 7. Same title, same topic, same notes, same homework problems. Geometric sequences at the top as well. Again, 5-1 if you're in Mod 7. 4-27-20 is the date if you're Mods 2, 3, and 4. Okay? All right. Continuing our chapter with sequences and series. If you think back to our last section of notes, the title was Arithmetic Sequences, and it was a bunch of numbers written in a certain order where the next number was found by taking the previous number and adding the common difference to it. Okay, geometric sequences, that's your title. Put an arrow down just like we did the other day with arithmetic sequences and write the following important definition, okay? Definition says, any sequence of numbers in which the next number is found by taking the previous number and multiplying that number by the common ratio. And I've underlined the words multiplying and the word ratio. So instead of adding the same number over and over to create our pattern, we're going to take that previous number, whatever it is, and we're going to multiply each number by some number to create the next number. Okay? So I'll give you a little bit more time here. Copy down this definition so you're aware of the definition for geometric sequences. Not only write it, but kind of read it to yourself, see if it makes sense. Any sequence of numbers in which the next number is found by taking the previous number and multiplying it by the common ratio. Okay? All right, examples. And I've got 3 of them listed here. We'll just call them numbers 1, 2, and 3 and then go ask questions concerning them here in a minute. But for now, let's just jot down these 3 examples of what's called a geometric sequence. The first one says 5, 10, 20, 40, ... Now again, these are infinite sequences that go forever. You can always put a ... if you've established a pattern and can indeed tell what the next number is. In this case, the number you start with is not relevant. What is relevant is what are you doing to that number to create the next one. Now, obviously, you've always got to have at least more than 2 numbers to create a sequence. If I only had 5 and 10, you don't know if I'm adding 5 or if I'm multiplying by 2. There's not been a pattern established yet. That's why at least a third number, usually a fourth number, is needed to try to create the pattern and then create the ... scenario. Obviously, we're multiplying each time by 2. So notice in the parentheses, I have R equals 2, not D. There's not a common difference here. There's a common ratio. Oh, we're multiplying by 2, multiplying by 2, multiplying by 2. So there's a ratio of 2. Now, the numbers there are obviously in ascending order. They're getting bigger and bigger. So do you agree the ratio had to be a number bigger than 1? However, what if your sequence of numbers was in descending order and the numbers were getting smaller and smaller? Like this one. Number 2 says 4. 2, 1, 1/2, 1/4, 1/8, comma ... Again, an infinite geometric sequence. Now, remember I warned you the other day that when looking at an arithmetic sequence, you never use the word subtract? Well, I'll warn you today, on a geometric sequence, you never look and say, oh, they're dividing by 2. You don't use the word dividing by. It's always multiplying by a common ratio. So guys, to correctly describe this sequence you're looking at, we're what? Taking the previous number and we're multiplying by 1/2. 4 times 1/2 is 2. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 1/2 times 1/2 is 1/4. And 1/4 times 1/2 is 1/8. Oh, so instead of what's the pattern? And you say dividing by 2. No, you're multiplying by 1/2. So my R, my ratio value, is equal to 1/2. And guys, you could even create a geometric sequence where the signs are what? Alternating. All right, if that's 2, and then the next number is -6, and then the next number is 18, and then the next number is -54, if you thought about it, how are you creating each successive number? Aren't you multiplying by -3 each time? So my ratio is equal to -3. Okay? With those 3 examples listed on your paper, these are the types of questions certainly we can now ask. So on your paper, kind of put a star and write, so let's find the next 3 terms for each of the above examples. You really don't have to write that probably, but I did to dictate what we're going to do right now. So with those 3 examples written, let's see if we can find the next 3 terms for each of the above examples, just like we did the other day with arithmetic sequences. Okay, guys, do you agree if we look at sequence number 1, 5, 10, 20, 40? Oh, I'm multiplying by 2 each time. So I'd have what? 80, and then what? Times that by 2, 160, comma, times that by 2, and get 320. Piece of cake. Number 2, our ratio is 1/2, correct? So we're multiplying by 1/2 each time. And again, I'll point out, like I did the other day, if the original sequence is written in fraction form, your answers now should be in fraction form. Don't start giving me decimals, even if you use a calculator to help figure out a missing number. So if I multiply by 1/2, that'd be what? 1/16, comma, times that by a ratio of 1/2, and we get 1/32, times that one more time by 1/2, and we get 1/64. And finally, number 3. Oh, it looks like I'm multiplying by -3. So if I take, now I might need a calculator here. If I take the last number I left off with, -54, and I times it by -3, I get, looks like 162. I'm now going to times that by -3 on my calculator, get -486, times that by -3, so times -3, and I'm at 1458. Okay? Now, the next question, kind of like the question we asked the other day, and this is when it gets a little tougher. How would you find, let's say, the 14th term of example number 1? Wow, what would the 14th number be? Now, again, we've got 5, 10, 20, 40. That's only 4 numbers. I sure don't want to start writing all those numbers and go all the way out to the 14th number, right? Because again, I could have said, what's the 114th number? So guys, we don't rely on writing them down. We rely on another formula that's important to memorize here. To find the 14th term or the 18th term or the 58th term, the formula is A sub n, because I'm trying to find the nth term of this sequence, is found by taking, okay, here's our formula. You take A sub 1, the first term, multiply that by whatever the ratio is, and that ratio is raised to the n minus 1 power. So back to our example here. They want the 14th term of example number 1. So here we go. A sub 14, the 14th term, would equal, now A1 means, of course, the first term. Well, I look, and the first term, of course, was 5, and that's dot connected to our common ratio, which we saw in that first problem was what? 2? Are you thinking with me? Oops, there we go. Sorry about that. We got a sub 14. The 14th term would equal the first term, which was 5, times the common ratio, which is, of course, 2. And that ratio is raised to the n minus 1 power. Now, since we're looking for the 14th term, n would be 14. So 14 minus 1 is, of course, 13. Now, guys, some of you did not use the order of operations correctly on your last homework assignment. All right? Order of operations says always do exponents first. Don't take 5 times 2 and get 10. The ratio is what's being raised to the 13th power. So on my calculator, I'm hitting 2 raised to the 13th power, which is 8192. So it's really 5 times 8192, which is, okay, back to my calculator. Wow, who would have thought that the 14th term grew all the way to the number 40,960. Okay? So with that formula in mind, now let's recall example number 2. 4, 2, 1, 1/2, 1/4, 1/8. With that formula on your paper, my next question says, I'm putting a star by, what's a sub 15? What's the 15th term of example number 2? Oh boy. Okay, I'm going back to my formula. The formula, this is just a note to myself. I'm trying to memorize it and learn it. A sub n, the nth term of any geometric sequence, is found by taking a1 and timesing it by r to the n minus 1 power. If that's memorized, here we go. I want a sub 15, don't I? The 15th term. So a sub 15 equals, a1 is the first term. Well, if I think back to example number 2, the first term was what? 4? So that's 4 times, now my ratio was a fraction of 1/2. And they want me to raise that to the n minus 1 power. Well, since we're looking for the 15th number, 15 minus 1 is 14. Now, guys, do not take out a calculator and hit 0.5 raised to the 14th and then times it by 4 and give me some decimal. If you look at the original problem, it's in fraction form. So what I want you to do correctly to give me an answer in fraction form is write 4 times, now watch this. Do you agree that if I took 1 and raised it to the 14th power, 1 times 1 times 1 times 1, etc., is of course just 1. So the question becomes, what's the bottom number going to turn into? So I'm pushing 2 to the 14th power on my calculator. 2 caret 14, enter. And I'm getting 16,384. And now of course, I'm going to cross cancel that with this 4, correct? So aren't I calculator-wise now taking this bottom number and seeing how many times 4 goes into this to cross cancel? So divided by 4, enter. Wow, 1 stays as my numerator, and my top number, who would have thunk it, jeez, is 1 over 4,096. Okay, that would have been the 15th number if you would have kept writing them all out. And then finally, we'll end the notes with a thing similar to what we did the last section. What if my last question said that, what is a sub 12 of example number 3? I'm sorry, it's not similar to that last section we did. We were looking for the first number then. We're not doing that today. Right now, because the signs could alternate, they want to throw one more of these at us. What's the 12th term of example 3? Now, of course, I'm going back to that formula right there. Right? You got to know your formulas. We're looking for a sub 12. A sub 1 was what? Okay, what was example 3? It's the one that said 2, then -6, then 18, then -54. Remember, our ratio was -3 because that's the number we keep multiplying by. Obviously, the first term is a 2. So my first term is 2. My ratio, we just said, was -3. I'm going to raise that to the n minus 1 power. So if we're looking for the 12th term, 12 minus 1 gives me 11. So on my calculator, now careful guys, make sure you put the -3 in parentheses. If you don't, it will not give you a negative answer like it's supposed to on an odd power here. You're putting parentheses, -3 raised to the 11th, getting 2 times what says on my screen, -177,147, believe it or not. A negative number raised to an odd power is always a negative answer. So timesing these together, I'm now going to take that number on my screen and times it by 2, gives me -354,000. Wow, 294. I certainly didn't want to write out all 12 terms and eventually get to this number when I can use that nice simple formula to calculate the nth term for me. Okay? All right, 2 days of sequences. One was arithmetic, the other was geometric. We'll continue with this idea tomorrow, but for now, your small homework assignment, go ahead and hit pause and leave this up there on your screen or quickly copy down these questions. I've got 3 different geometric sequences. 1, 2, 4, 8, 50, 10, 2, ... 3, -6, 12, -24, ... On the first one, I want you to find the next 3 terms and then find the 13th term. On sequence number 2, I want you to find the next 3 terms and then find the 10th term. And on sequence number 3, find the next 3 terms. Just practice pattern recognition and calmly sensing the pattern and finding the next 3 numbers. And then, I wonder what the 9th term would be for that one, a sub 9. Of course, you're practicing your formula on question B for all 3 of those. Okay? So that's your homework. Those are your assignment problems. That's going to be your daily grade. Yes, you get points for trying them, but guys, you also get a point or lose a point depending on whether you get it right or not. So you're approaching these as a daily little quiz, and you're going to submit me what you think the answers are to these questions, okay? Great job. We'll see you tomorrow.